Okay, looking at this first equation, we have 1 minus 10 over x equals negative 21 over x squared. And I see Kayla sent me an answer. I'm going to give you extra credit for that. And since this is a fractional equation or a rational equation, whichever you want to call it, what you're going to have to do is first find the common denominator. And since this one is a whole number, it's not a fraction. In order to keep things looking the same, any whole numbers we're going to put over 1. And my denominators, remember, the first thing I'm going to do is find the least common denominator. And my denominators are 1x and x squared. So there are no numbers that we have to work with, but the letters are the highest exponent is x squared. So my common denominator is going to be the x squared. I'm going to have to rewrite each of these fractions with x squared as their denominator. I'm going to have to go right here. Okay. How do I do this? I look at each denominator. This is 1. I divide the 1 into the x squared. It gives me x squared. That means I have to multiply the top by x squared, and I get x squared as my first numerator. Then I divide the second fraction, the x, into the x squared. That gives me x. Because remember, when you're dividing, you're subtracting exponents, and this exponent is 2, this exponent is 1. We're getting an exponent of 1, so we're getting x to the 1 or just plain x. And we're going to multiply it by the 10, and we're going to get 10x. And finally, we do the x squared and the x squared, it cancels out. So all I'm left with is 1, and 1 times negative 21 is negative 21. So I have rewritten each of these fractions with the same common denominator. I then, because it's an equation, can just write the equation of the numerators. So high up. The numerators are going to be x squared minus 10x equals negative 21. By finding the common denominator, I'm able to get an equation that doesn't have any denominators at all. Remember, I can do this because it's an equation. When we have just adding of fractions, we can't get rid of the denominator, but we can when we are writing equations. Of course, this is now a quadratic equation because it has an x squared in it. So I'm going to add 21 to both sides in order to get everything equal to 0. So I get x squared minus 20x minus 10x plus 21 equals 0. And I then I'm going to want to factor it. And since my leading coefficient is 1, I can right away go to my 2 parentheses and break it up into the x and x. Remember, I then go to the last term. Since it's a positive number, it means both signs are going to have to be the same. So I have to look at the middle, and they're both going to have to be minuses. And I'm looking for numbers that multiply to 21 and add to 10, which is going to be the 7 and the 3. And then I set each of these individually equal to 0. So now on this one, I'm going to add 7. And this is going to give me x equals 7 for one answer. And here I'll add 3. And that'll give me x equals 3 as our other answer. We're getting 2 answers because we ended up with a quadratic equation. My 2 answers are 3 and 7. You don't have to put them in these brackets, but here's your answer. We really have to check that these are not what we call extraneous roots, that neither of these numbers are going to make a denominator equal to 0, because if it does, we can't use that answer. So in this case, obviously 3 won't make any of these equal to 0, and neither will 7. So these are good answers. Here's my solution to this equation. Again, it means finding the common denominator, changing all the renaming all the fractions so they have that common denominator, and then just working with the numerator. The second question is not an equation, it's just a matter of we have 2 fractions and we want to combine them. But again, in order to add, subtract, or solve equations, the first thing we've got to do is find the LCD, the least common denominator. And since over here it wasn't a problem because all the denominators were single terms, monomial. But here I have binomials. So when I have binomials or any trinomials, I've got a factor. And the x plus 4, of course, can't be factored, but the x squared minus 16 can be factored to x plus 4 and x minus 4. And after we factor them, what we do to find our common denominator, to find our LCD, is we start with our first fraction, and it has a denominator of x plus 4. So I have to take everything that I see in that first fraction, which in this case is not so much, it's just x plus 4. Then go to the second fraction. Now notice what I'm going to now start putting in additional things, depending if I already have it or not. Now, I already have the x plus 4, so I don't have to put that in. But I don't have the x minus 4, so I have to include that as part of my common denominator. Now, there's nothing more to do. So my least common denominator, my LCD, is x plus 4 times x minus 4. And again, after we've found our least common denominator, we have to rename the fractions so they all have the same common denominator. And remember how I do it. I take the original denominator, x plus 4. I already have that here. And see what I didn't have, and I didn't have an x minus 4. So I'm going to have to take this x minus 4 and multiply it by 1, which will give me as my first fraction x minus 4 over the x plus 4 times the x minus 4. Now don't start canceling things out. You can, when you're adding and subtracting, you only cancel out at the very end. Over here, we have the x plus 4, and we also have the x minus 4. In fact, that's why it's very good to write them right below each other, which means nothing new has been added to the denominator. I haven't multiplied the denominator by anything, so I can just leave the numerator alone. Once I've done that, I just take the numerators, the x minus 4 plus the 8, and combine those. Well, that's really easy to combine. Minus 4 and plus 8 gives me x plus 4. And after I totally combine, if this was a minus, I would have subtracted. If it's a plus, I added. I put it over the common denominator. Remember, when you were solving the equation, you didn't have to go back and put it over the common denominator because you were going further. You were finding out what x is. But over here, you're just simplifying. You're just combining. So after you combine all your numerators, you put it over the common denominator. And then you see, can you reduce anything? And yes, we can see that the x plus 4 on top and the x plus 4 on the bottom, remember, have to be the identical binomial, can be canceled. Notice nothing was left on the top, so I could put a 1 there, so my final answer becomes 1 over x minus 4. A lot of work for something that doesn't look so very complicated. Okay. I'm going to do one more example of this type and then go on to something new. I just want to mention that you should see that if you go on the Delta Math, there are new assignments. I think that there are going to be, starting today, probably 2 new assignments, maybe a third one. They have different due dates, but they're all have to do with this chapter that we have been doing now. Yes, this would be the final answer. Notice this is not an equation. It's not asking you to figure out what x is. There's no equal in this. So therefore, your answer is just a fraction. Whereas this, it said to solve, and there was an equal sign, so you have to go all the way until you figure out what x is. So in that case, your answer is, you could just write 3 and 7, or you could write x equals 3 and x equals 7. If you were doing this on Delta Math, all you'd have to write was the 3 and the 7. You'd have to make sure to write both answers. Whereas if you wanted to, if you were doing something like this on Delta Math, you'd have to write the whole expression 1 over x minus 4. Does that answer your question, Naya? Okay. All right, so I've noticed that there are a couple of people who have not done the midterm as yet. This, I still kept it posted because I saw there were people who still had to do it. But please make sure you get it done, because if you don't get it done, I have to submit who I suspect might not pass this course. And if you haven't done the midterm, and obviously I'm assuming you're not going to pass the course. So make sure you do it. If you didn't get a good mark on it, most people did very well, then email me and we'll see if I can give you another chance to do it. It wouldn't take away the bad mark, but at least I might, like, let's say you got a 50 and then you did it over and you got a 90, I would count that as a 70. In other words, I'd average the 2 marks. Yes, this is going to be on the final. This is the first chapter after the midterm, and this is going to be on the final. The final will include everything from the beginning of the term. In other words, half your final is going to be, or at least a third of your final, are going to be those questions that you saw on the midterm. Obviously not the exact question, but those type of questions. And the final will include everything from now on. There is going to be a quiz on Delta Math shortly. Make sure you do the homeworks and the quizzes on Delta Math. What I do is, for anybody who's done all the work on Delta Math and all the work, any of the quizzes, which includes the pretest, because that was supposed to be a quiz for class. If you do all of them, then I will drop the lowest mark and just count. There'll probably be 3 or 4 of those in the quizzes and etc. And I'll drop your lowest mark. Obviously, if you haven't done all of them, I won't drop your lowest mark. In other words, I count the best. I'll let you know whether it's going to be the best 3 or the best 4 of your marks. So it's to your advantage to do as much of the work as possible. Let's do just one more example like this, and then we'll continue something new. let's say I gave you this problem. I'm asking you to solve this equation. And you know we've got to get a value for x. And it's 2x over x plus 4 minus 3 equals -8 over x plus 4. And I will give you a few minutes to do this while I take attendance. Remember, it's a rational or fractional equation. You could call it either name. And what you have to do is get your common denominator and then rewrite all your fractions with that denominator, and then you can write the equation. Okay. Please listen for your name. Olivia. Isis.
Here.
Good morning.
Good morning.
Okay, once we're in November, you know that we're in the home stretch because the final is sometime in the middle of December, so we don't have very much time left. Alvaro Blake. Lewis. Emma.
I'm here. Good morning.
Good morning.
Good morning.
Demetrius.
Good morning.
Good morning. Desmond. Shania.
I'm here.
Good morning. Caden. Kayla. Kayla, I know you're here. Okay, thank you. Sanjita.
Here.
Good morning. Oriana.
Yes, I'm here.
Good morning.
Good morning.
Tahira.
I'm here.
Good morning. I know you're here. You're my first one. Pleasure to have you. Michaela. Kiana. Carleaf.
Here.
Okay, that's your Kiana, right? Okay.
Yeah.
Okay, is Carleaf here? Yeah, I see. Thank you. Jenna.
I'm here.
Hi.
Also, did you receive my midterm? I did it yesterday.
When did you do it?
I did it yesterday.
No, it did not come up on my. I checked this morning on my. Did you see a mark? Did you look in your grades and get a mark?
Did I look at my grade on Blackboard?
Yeah, and you can just look on grades on the Blackboard, on our Blackboard account. There's a thing that says grades, and you can see your grades for that course.
Yeah, I see it.
Okay, then I should be able. It maybe my computer had maybe it was still from the night before.
Oh, okay, and also I'm gonna be doing the pre one because I just saw it. I'm gonna do the pre one as well.
Okay, after class I'll check. And if I don't see it, I'll get in touch with you. Tatiana.
Here.
Good morning.
Good morning.
Naya, I know you're here because I've seen you. Kazandu.
Good morning.
Who just answered good morning? I'm sorry.
Nah, yeah, I did.
Oh, yeah, I saw you sent a text, so I didn't even listen for you. Trina. Jean Thomas.
Yeah.
Good morning. Okay, so I have everybody. Okay, again, if you did not do, if you're missing any, you're going to see, I'm going to send you out emails probably over the weekend. And if you're missing anything, I'm going to let you know what you're missing, but it's your responsibility to make up the work. And if you haven't taken your midterm yet, make sure you do it. As I said, I left it up because I saw there were still people who hadn't taken it, but really, anybody who doesn't take it by today, I'm gonna start.
Well, did you get mine? I did it yesterday.
You know what, if
I'm gonna email you.
okay, I'll email me if I'm gonna email anybody who didn't do it.
Okay, thank you.
And if you don't get an email from me, then you know that you've got it.
All right.
Or maybe maybe I'll do an email for the people who did it and those who didn't do it, so then it'll be clear.
Okay, thank you very
Okay.
much.
I would say 3/4 of people have done it. It's just, there are some people who haven't. Okay, I see, Naya, you sent me an answer. Let's see if that's the right answer. Giving you extra credit again. We're going to put this 3/1 so that everything looks like it's fractions. And we're going to find our common denominator. And if you notice, the common denominator is really very easy because the only denominator I'm really seeing is x plus 4. This is a 1, so that's just anything goes into 1, and 1 goes into anything. So my common denominator, I don't even have to do any factoring or anything. My common denominator is going to be the x plus 4. So I'm going to have to rewrite all these fractions. Remember, when we're doing a fractional equation, we're going to find the common denominator, and then we're going to rewrite the numerators, and then just write the equation of the numerators. So I look at this is x plus 4, and this is x plus 4. I haven't changed the denominator, I just leave the numerator alone. But with this one, my new denominator is 1, and I want it to be x plus 4. So I'm going to have to multiply by the x plus 4. I'm going to have to do 3 times x plus 4. And over here, I again have the x plus 4 as a denominator. I'm not changing the denominator, so I'm leaving the numerator alone. So if I look at it, the only thing I really had to do was take this 3 and multiply by x plus 4. Here's my equation now. 2x minus 3. Notice I'm being very careful. I'm putting this in parentheses because I want to make sure I multiply by the whole thing. So I end up with just a regular equation without any denominators, just the equation of the numerator, the 2x minus the 3 times the x plus 4 equaling the -8. And now I go ahead and remove the parentheses. So this will give me 2x minus 3x minus 12 Remember, because I'm multiplying this 4 by the -3, it's giving me -12 equals -8. And 2x minus 3x gives me -x. Of course, I have to add 12 to both sides. So this is giving me -x equaling +4. Because -8 plus 12 is 4. Be very careful. Over here, this is a -12. It's not a +12 because this negative applies not only to the x, but it also applies to the 4. It's -3 times x plus 4. That's -3 minus 12. Something we have to be very careful about. Notice this is not what x is because it's -x. So I'm going to divide everything by -4. So I get as my final answer -4. So it turns out that my answer is, my solution looks like it's -4. But remember what I told you have to do. When you have rational equations, when you have equations with fractions, you have to make sure in the end that your denominator does not turn out to be 0. We have to go back. We've been doing it and talking about it, but here I'm going to show you exactly what's happening. When I replace, if I were to check and I replace the x by -4, I'll get 2 times -4 over -4 plus 4 minus 3 equals -8 over -4 plus 4. And when I try to simplify this, I get 2 times -4, which is -8 over 0, and I stop right there. Anytime I get a 0 in the denominator, it telling me that the answer I got is wrong. The answer is you cannot have a 0 in the denominator of a fraction. And if our answer, this means that this answer is no good. I don't even have to go further on the checking. As soon as it makes any denominator equal to 0, I've got to throw out that answer. It's called an extraneous root. The word extraneous means extra, that's no good. We can't use it. So if -4 is not the answer, what is their answer? There is no answer. There's no solution to this problem. Sometimes we write just no solution, or sometimes you remember we get this 0 with a line, a slash through it to tell us there's no solution. You can write either no solution or you could just write this symbol. But this question happens to be all that work and we did got nothing. There is no solution. So that's something we have to be very careful to be aware of, that once you finish your problem, and if you had done this as a multiple choice and you picked -4 as your answer, you would have thought you did it right, but your answer would have been wrong because -4, even though we did all the work correctly, this is what happens with what we call an extraneous root. We can do all the work correctly, but an answer pops up that is really not right. The reason it popped up is because it made the denominator 0. We cannot have a situation with 0 in the denominator. We can't divide by 0. It's the one operation of adding, subtracting, multiplying in denominator and dividing that we cannot do. You cannot divide by 0. You can divide by any other number. You might not get an even answer, but you'll get an answer. But when you try to divide by 0, you get no answer. It's impossible. 0 is not something you can divide by. All right, we're going to stop. This pretty much takes care of working with rational expressions and solving rational equations. the one last topic that we want to do in this chapter is what's called dividing polynomials. How do we divide? We learned in chapter 4 how to add, subtract, and multiply, and also factor algebraic expressions. But what we didn't do is divide polynomials. And we want to know, how do we divide? Notice factoring and dividing are two different things, and we want to know, how do we do division? So first of all, let's talk about dividing a polynomial by a monomial. What if I were to give you a problem that looks like this? 10x to the third minus 15x fourth is 20x over 5x squared. Now what we have here is a polynomial. Actually, it's a trinomial because it's 3 terms over a monomial. And you have to be very careful about what it says. Are we told to simplify this, or are we told to divide? In this case, we're talking about dividing. Let me just show you the difference between, with regular numbers, so you'll know the difference between dividing and simplifying. In regular fractions, if I tell you, let's say, to divide um, 15 by 6. Notice I'm writing it as a fraction, but I'm using the word divide because one way of showing division is by using the fraction sign. Actually, whenever you have a fraction, what you're really indicating is a dividend, something you're dividing into, divided by the divisor. The divisor is the denominator. Now, if I ask you to divide 15 by 6, that really what I'm telling you is to take out your calculator and actually do 15 divided by 6. And if you do that, you're going to get 2.5. In other words, you'll either get a decimal answer, or if you wanted, you might write it as 2.5. If you wanted to write it in fraction form. But usually when we're doing division, we use our answer, we give our answer as a decimal. Sometimes we also do, let me leave that for a minute. If I would have told you to simplify (15/6), what that would mean would be to reduce the fraction, which means find what's a common number that the greatest common factor of both the numerator and denominator, And obviously that's 3 because 15 divided by 3 is 5. And 6 divided by 3 is 2. And we've simplified our fraction to 5 over 2. Now, obviously 2.5 or 2.5 is the same as 5 over 2. But we have to understand when we're simplifying, we're just trying to reduce the fraction. But when we're dividing, we're actually going ahead and taking and dividing into it until we get the thing in, as I said, in decimal form. Okay, so how does that affect what we're talking about right here? I told you I want you to divide this. Whenever you're dividing a polynomial by a monomial, what you have to do is divide each term separately by the denominator. In other words, we rewrite this as 10x to the third over 5x squared minus 15x to the fourth over 5x squared plus 20x to the fifth over 5x squared. We take each term of our numerator of our polynomial and put it individually over the denominator. And what you then do is you simplify each fraction individually, which we know how to do because we've done this before. We first look, let's take this first fraction. We have a 10 and a 5, so we can cancel out the 5 and we'll be left with 2 on the bottom, on the top, and the 5 cancels out. And the x cubed and the x squared, we can cancel out. Remember, always when we're canceling out, it's the lower exponent, which is the x squared. Notice I now have to put a 1 there because I've gotten rid of everything in the denominator. And I do the 3 minus 2 because when I'm dividing, I subtract the exponent. So that gives me 2x over 1 for our first term. I then go to the second term, do the same thing. I have a 15 and a 5. I can cancel out the 5. This will give me a 3 on the top, and the 5 cancels out. The x fourth and the x squared, I can cancel out the x squared, and 4 minus 2 is 2. So my second term becomes minus 3x squared over 1. And finally, my last fraction, I can cancel out the 5 and the 20, and I'll be left with 4 on top. X squared gets canceled out. X5 minus 2 is 3 is x to the third. So the last thing is 4x third over 1. After you've done all that, any term, any fraction that's over 1, you can write it without the 1 on the bottom. So we could really write this as 2x minus 3x squared plus 4x to the third. And that would be the result of dividing this polynomial, this trinomial, by 5x squared, the monomial. Okay, I'm going to give you one to try on your own. Okay, can I erase this?
Not yet. I'm trying to copy it. Okay, you can erase it.
Thank you, thank you.
All right.
Okay, here's one for you to try. We have 15 a third b minus 30 AB third plus 15 A squared B squared. I'm dividing that trinomial by the monomial 15 A squared B squared. Okay, I'll give you a couple minutes to try that. Okay, let's work on this together. Just like we said before, what we're going to do is, since I see it says divide, and I have a polynomial divided by a monomial. This is a single term. There's no pluses or minuses in there, in between the letters or the numbers. I'm going to separately put each term from the top over the monomials. So first I'm going to have 15a to the third b over 15a squared b squared minus 30 ab third over 15 a squared b squared plus 15 a squared b squared over 15 a squared b squared. So I just rewrite it so each term from the top is individually over the denominator, so we get three separate fractions that we're now going to simplify. So we look here, there's a 15 and a 15, I can cancel those out. Then I look at the letters, a third and a squared. Remember, I cancel out the one with the lower exponent and subtract that number from the top. 3 minus 2 is 1. So this is a to the 1, or just plain a. Then I have b and b squared. The lower exponent is the b, because this is b to the 1. So that gets canceled out. And 2 minus 1 is 1. So this becomes b. Notice the b is in the denominator because the lower exponent is the one that gets canceled out, and that was on the top. And you subtract the lower exponent from the higher one and leave that where the higher exponent was. So if I look at this, all I'm left with from that first fraction is a over b. Notice the b is in the bottom. Okay, now we're going to the next fraction. I have a 30 and a 15. I can divide by 15. I get 2 here, and this cancels. The a and the a squared, the a cancels out because it's a lower exponent, and 2 minus 1 is 1, so I get a on the bottom. B cubed and b squared, the b squared is the lower one that gets canceled out, and 3 minus 2 is 1, so I get b on the top. So my second fraction becomes minus 2b over a. Notice you have to be careful because there's a lot of crossing out. And if you just scratch it out, you're going to end up with such a mess that you're not going to be able to see it. Finally, we have 15 over 15, that cancels out. The a squared and the a squared cancel out. And the b squared and the b squared cancel out. Everything cancels out. What I'm left with, don't leave it empty. You're left with 1. When you're doing division and everything cancels out, your answer is 1. And this is not an equation. We can't solve it. This is my answer. A over b minus 2b over a plus 1. Notice when I start with 3 terms in my numerator, my answer also has to be 3 terms. I'm not left with 0. I'm left with over here 1 and a over b minus 2b over a plus 1. All right. So now let's go on to what happens if I take a polynomial, let's say a trinomial, and divide it by a polynomial. Now we're going to restrict ourselves to dividing by binomials because polynomial division itself is quite difficult. And I'm going to go through each of the steps, and I'll do one with you and then 1 or 2 with you, and then I'll give you a chance to do one on your own. So what we're going to use when we're dividing polynomials is something called long division. Now, you must have learned long division when you were in elementary school, but most of us just use calculators, so we might have forgotten the steps involved in division. So I'm going to do a long division example, and show you how to do it with just regular numbers. Because if we look at the steps that we use in long division, that's going to help us when we want to do long division on polynomials. Okay, so I'm dividing the number 25 into the number 4,628. And of course, I can't divide 25 into the whole thing, so I just go and I do, well, the 25 can't go into the 4, but the 25 can go into the 46. So I do 25 into 46, it goes once. And notice, you remember you put the 1 over the 6 because you're not putting it over the 4 because you have to make sure that you're leaving the space. Okay, once you've divided it, you take what you put on top, which is the 1, and multiply it by the divisor to 25. So 1 times 25 will give you 25. And you put it underneath your 46. So look at, let's just write down the steps. We divided. And then we multiply. We multiply the top by what we put on top with the divisor. And the next step is we're going to subtract the 46 minus the 25. So this is going to give me 1 and this is going to give me 2. So the next thing is I subtract. And after I subtract, then I bring down the next number. Now the next number happens to be 2. So now I have 212. I am now going to divide the 25 into the 212. Well, just you can use your calculator to do this a little bit, but the biggest number that the largest number of times that 25 can go into 212, I think, is 8. Let's try 8. Now notice I'm putting the 8 over the 2 because that's the one I brought down. And now I'm starting the process all over again. I divide it. Now I have to multiply. Now I don't multiply by the whole 18. I just multiply by the number I put on top. So I do 8 times 5 is 40. 2 times 8 is 16 and 4 is 20, and I get 200. After I multiply, I subtract. So this gives me 12. And I bring down the next number, which is 8. And I start all over again by dividing 25 into 128. It looks like 5. Notice I'll know if I didn't get the right number is if this is too big, then I can't subtract. Or if after then I know I have to go bigger, I have to go smaller. And if this gives me a number more than 25, then I have to go bigger. Okay, I take now the 5 that I just put on top and I multiply by it. 5 times 25 is 125. And I subtract, I'm left with 3. And then I bring down the next number, but there's no next number to bring down. Now, if you would have put this into your calculator, it would have put zeros there. Really, it wouldn't show you that it's doing that, but it would go into decimals. But sometimes what we do is after we get to the decimal point, we don't want to get an answer with decimal. We take our remainder. The last number is called the remainder. And I put it over the divisor. This is called division with remainder. So my final answer becomes 185 and 3 over 25, or alternatively, so we could write it, my answer as 185 with a 3 over 25 next to it. Remember, when you have a whole number right next to a fraction, it means this is what we call a mixed number. This is the whole number, this is a fraction. Or you could write it as 185 remainder 3. Sometimes we just write what is the remainder, our remainder 3. But this is how we do long division. Let's see how that applies to dividing of polynomials. So let's say I'm going to go over here. Here's what I want to divide. I want to divide 2x squared minus 7x plus 9 by x minus 2. And notice I use the term divide. We are not trying to simplify this fraction. We are trying to divide. But what we have here is a polynomial. It happens to be a trinomial divided by another polynomial. Notice my divisor is not a single term anymore. We can't do it the way we did it before. We have a binomial as my divisor. So the first thing I have to do is write it like a regular division problem. In other words, the x minus 2 is my divisor that goes on the outside. The 2x squared minus 7x plus 9 goes on the inside. Just like regular long division. We're using long division to divide polynomials. We have to be very careful, though, when we look at what we have here, that it's in what we call descending order. If the terms are not in the right order, I've got to put them in the right order. The x squared term first, the x term, then the number. Okay. Now we're going to use these 4 steps. We're going to divide, multiply, subtract, bring down. Now, when it comes to dividing, it's very hard to divide by a whole x minus 2. So instead of dividing by the whole x minus 2, let's just divide by the x and use that as a, let's see if it gives us an answer that we could put on top. Now, when I divide x into 2x squared, in other words, I divide the first term into the first term. Remember, this is understood to be a 1, so 1 into 2 gives me 2. And x into x squared gives me x. X into 2x squared gives me 2x. Now notice I put it on top. I don't even care where I put it on top. I don't have to be careful like I was with the numbers. Here I can put my, just put my answer right on top. After I divide my first term into my first term. I got an answer of 2x. I take that answer that I just put on top and multiply it. But when I'm multiplying it, I multiply it by the whole binomial. I do 2x times x, which gives me 2x squared. And 2x times -2, which gives me -4x. Notice, since I have a monomial that I'm multiplying by a binomial, I'm ending up with 2 terms. So one will go under the first term and one will go under the second term. Okay, after we multiply, we now have to subtract. Now, this is, remember, we're subtracting. We have to be very careful because of these side numbers. So here's what I like to do. To make sure that I'm doing my subtraction correctly, I take the original sign, which in this case is a plus, and I remember one of the ways to do division is to change the sign. So this is going to become a minus, and this one is going to become a plus. I do that because it's very easy to make a mistake. So I'm always going to be changing the signs using that method of subtraction of sign numbers. So first I'll have a 2x squared minus a 2x squared, which will cancel out. And here I'll have a -7x plus a 4x. Remember, what we're subtracting is a -4x. That's why it's a negative, and -4x becomes a plus 4x. So this gives me -3x. Be very careful with your sign. Okay, after we subtract, the next thing we're going to do is we're going to bring down the next term, which is the +9. And now we start to process it all over again. We take our first term of our divisor and divide it into the first term. X into -3x gives me -3. Again, it doesn't matter where on top you're putting it. You don't have to be so careful about that. But whatever after you've divided, you take what you just put on top, which is the -3, the whole -3, and multiply by it. So -3 times x is -3x. And -3 times -2 is +6. After you multiply, you subtract. Now, remember what we said, when we're going to do the subtraction, we're going to do it by changing the sign. So this is going to become a plus, and this is going to become a minus. And now I have -3x plus 3x, which cancels out. That should always happen, that first number cancels out. And then we have +9 minus 6, which is +3. And there's nothing more to bring down. So this is our remainder. You'll recognize it as a remainder because it doesn't have any x's left in it. So my answer is, either we could write it as 2x minus 3 remainder 3. Sometimes you just ask, what is the remainder? The remainder is 3. Or you can write it as 2x minus 3 plus your remainder, your 3, over your divisor, the x minus 2. Just like we took that 3 and put it over the 25, we could do this 3 and put it over x minus 2. You can't just put it next to it. You have to actually, whereas with numbers, you don't have to put that plus. Over here, you have to put the plus, or if it's a negative, the minus. But this would be your answer in what we call remainder form. Answer divided by and remainder. Okay. I know this is a lot of steps, so I'm going to do one more with you, and then I'll let you try one. I'm just looking for a problem off of the final, so that I can give you one to try off of final. Okay, so this is the one I'm going to do. We have, again, it's divide, and it says divide 6x to the third plus 7 minus 4x over divided by 2x minus 2. Okay, so the first thing is, I noticed that this is a polynomial. It's 3 terms divided by a polynomial, which means I have, since it's division, I have to set it up like a long division, which means I have to put the 2x minus 2 on the outside. And on the inside, I have to put the, what we call the dividend, the polynomial that's on top. And remember what I told you, you have to have this in descending order, which means you have to have the highest exponent first, so that's the 6x cubed. And once you have a 6x cubed, the next thing you should have is an x squared. Oh, there's no x squared term here. Well, if there's no x squared term, I have to put it in green. There are no x squared. I put a 0x squared. There, I have to leave a space for the x squared. I have to have if I'm starting with an x cubed, I need a space for the x cubed, a space for the x squared. The next thing I should have is an x, which is the negative 4x. And the next thing I should have over there is a 7. So not only do I have to have things in descending order, I have to have every term accounted for. If one of the terms is missing, like in this case, there was no x squared, I put a 0x squared or just a 0 for that because I need the place. I need to maintain its space. Okay, so now we've got it set up. Now we're going to do what we did before. We're going to take our first term and divide it into the first term. So 2 divided into 6 gives me 3. And remember, when we're dividing the variables, we're subtracting exponents. 3 minus 1 is 2, so this is 3x squared. The first thing I do is put a 3x squared on top because I divided 2x into 3x to the third. I now take what I put on top and multiply it by both terms. So 3x squared times 2x gives me 6x to the third. And 3x squared times negative 2 is minus 6x squared. Now you see why I needed that space. Where would I put the 6x squared if I didn't leave a space for the x squared? Okay, after I've multiplied, I have to subtract. So I'm going to change my signs. This is a positive 6x cubed, so it's going to become a negative. And this is a negative 6x squared, so it's going to become a positive. And when I do 6x cubed minus 6x cubed, that cancels out. And here I have 0x squared plus 6x squared, which combines to 6x squared. Notice it's a positive 6x squared because I had changed this. So this is a minus, and a minus became a plus. After I subtract, I bring down my next term, which is negative 4x. And I start the process again by dividing the first term into the first term. 2 into 6 goes 3, and it's going to be a positive 3. X into x squared gives me x. Don't forget, don't just put in the 3x, but put in the plus because these are individual terms. You have to connect them. After you divide, you take what you just put on top, which is a 3x, and multiply both terms of your divisor by it. So 3x times 2x is 6x squared. And 3x times negative 2 is minus 6x. And then we subtract, which means first we change our signs. This is going to become a minus because there's no sign, it means it's positive. But this is a minus, so it's going to become a plus. And now I do 6x squared minus 6x squared, and that cancels out. And then I have negative 4x plus 6x. This has now become a plus 6x. So this becomes 2x. And I bring down my next term, which is plus 7. Now you have to be careful. You have to line things up. You have to be neat. And start all over again. 2x divided into 2x. Everything cancels out. So what do I put on top? I put a 1. I don't put nothing. 2x goes into 2x one time. I put the 1 on top and multiply both terms by that 1. 1 times 2x is 2x. 1 times negative 2 is negative 2. And now I subtract by changing the signs. This is a positive, it becomes a negative. This is a negative, it becomes a positive. The 2x minus 2x cancel out. And 7 plus 2 becomes 9. And there's nothing more to bring down. There's nothing more. This is my remainder. So my answer becomes 3x squared plus 3x plus 1 remainder 9, or write it 3x squared plus 3x plus 1 plus 9 over 2x minus 2. Right, take your remainder, put it over the divisor. So your answer is 3x squared plus 3x plus 1 with a remainder of 9, or if you want to write it as a single, in a single format, this is your answer. Okay. Let's see if I can give you one to try on your own. Here, I'm going to erase this one over here. And since this is off a final, it's a multiple choice. I'll give you the choices. Okay, so we want to divide. Four x squared plus 6x minus 1 by 2x plus 1. And here are your choices of answers: A, B, C, and D. A, 2x plus 2 minus 3 over 2x plus 1. Choice 1. Choice B, 2x plus 4 minus 5 over 2x plus 1. Choice C is 2x plus 2 plus 3 over 2x plus 1. Notice how similar these answers are. You really have to do the work in order to get the right answer. And then you have 2x minus 2 minus 3 over 2x plus 1. Okay. So I'm going to leave this on the board for a few minutes so you can, leaving the instructions so you can look how to do it. And I'll give you about 5 minutes to try it, and then we'll do it together. And of course, if you have an answer, you can write either A, B, C, or D. Okay. I see that we already have an answer, so I think we can start working on this together. I'm going to erase this one so I could write it over on this side. So I can do the work. Okay, so. Let me just give Oriana extra credit. Okay. So I'm going to rewrite this as 2x plus 1 on the outside. And on the inside, I have 4x squared plus 6x minus 1. Notice I checked. This is in descending order, starting with an x squared. The next thing is next is a number. So everything's in order. Okay, so now I'm going to take my first term, 2x, and divide it into 4x squared. So 2 into 4 gives me 2, and x into x squared gives me x. After I divide, I take the 2x and multiply it by each of the terms of the binomial. 2x times 2x is 4x squared, and 2x times 1 is 2x. After I multiply, I'm going to subtract, which means this is going to become a negative, and this is also going to become a negative because it was originally a positive. And the 4x squared minus the 4x squared cancels out. And here I have 6x and negative 2x, which gives me positive 4x. I subtract, now I bring down the next term, negative 1. And start all over again. I take the 2x and divide it into the 4x. So 2 into 4 gives me 2. The x's cancel out. I now put a plus 2 on top. I take what I put on top, the 2, and I do 2 times 2x is 4x, and 2 times 1 is 2. And now I have to subtract. So this is going to become a minus, and this is also going to become a minus. And the 4x minus 4x cancels out. And negative 1 and negative 2 give me negative 3. So my answer comes out to be 2x plus 2 minus 3, my denominator, my remainder over the 2x plus 1, which is indeed choice number A. That was correct, Oriana, perfect. Okay, so here's where we're leaving off. We're going to be starting a new chapter on Friday. Don't forget to look out for Delta Math homework. And I think I'm going to be putting on, I'll let you know, a quiz for over the weekend on Delta Math on chapter 5, just to keep us current. Make sure that you're keeping track of and doing your homeworks and your quizzes so that you're on your make sure that you have all your marks in that you need. And if you haven't taken the midterm yet, this is extremely important. You must take it because otherwise you're going to be written down as failing for the course. Kayla, you want to ask me a question?
Yeah.
Do you want to do it in person, or you want to? Would you like to wait until everybody gets off? Hello?
Professor, what you said?
I The class is over, but somebody wanted to ask me a question. Kayla, so,
Have a
Oh,
good
so
day.
we can
Vanessa.
leave?
what, I'm sorry?
We can leave because she said the class
Yes,
is over.
yes.
All right. Have
Okay.
a great day.
Have a good
Okay,
day.
everybody have a great day. And I'll just we'll see you on Friday. Okay, Kayla, looks like most people. Yeah.
I was doing the homework and I wanted to know how you do the fraction on the thing.
How
You put a fraction on the
this is on the Delta math homework?
yeah.
Okay. You know what I'd like you to do?
Mm-hmm.
Send me an email as to which homeworks they are. And can you get on Friday a little bit earlier, let's say 5 to 8 or 8 o'clock?
Mm-hmm.
Because this is going to take a little bit more time than just, 1 second answer.
Mm-hmm.
Okay, and we'll go through, is it, the question basically is how to put the answers in or how to do the
Yeah,
problem?
how to put the answer. I be having the answer, but I just don't know how to put it in.
Okay, I would have to be looking at, I know that what you have to do is I would put let's say you wanted to put in, let's say 3 over 2x plus 1.
Mm-hmm.
Anything that's, first of all, the 3 is not a problem because it's just a single term. I would do 3. Then you put in your slant line, your forward slash.
Mm-hmm.
And then I would put a parentheses and write the 2x plus 1. And then you'll see it'll pop up as 3 over 2x plus 1.
All right.
Okay, so it's the forward slash is instead of the
The
fraction.
line. Okay.
If you still have a problem with any of them, then email me or just get on early and we can discuss it then.
Okay.
Okay, but don't worry too much about it. I mean, you want to be able to do it, but this is, as I said, you mostly have to worry about multiple choice questions.
All right. Thank you.
Okay, bye-bye. Have a good day.
You too.